Welcome to Session 8. Today, we meet the single most useful fact about triangles. A rule so reliable, you can build almost every triangle problem on top of it. No matter the shape or size of a triangle, its three inside angles always add up to the same total. Once you know that total, finding a missing angle becomes a quick subtraction. Here is the rule. For any triangle, the three interior angles, angle A, angle B, and angle C, always add up to exactly 180 degrees. It doesn't matter if the triangle is tall, wide, tilted, or tiny. The sum is always 180. Commit this to memory. A plus B plus C equals 180. This gives us an easy way to find a missing angle. If you know two of the angles, just add them up and subtract from 180. Whatever is left over must be the third angle. One rule, one subtraction, that's the whole technique. Let's try it. A triangle has angles of 50 degrees and 60 degrees, and we want the third. First, add the two we know. 50 plus 60 is 110. Then subtract from the total. 180 minus 110 leaves 70 degrees. So the third angle is 70. And to check, 50 plus 60 plus 70 is 180. Here's a right-angle version. Suppose one angle is 90 degrees and another is 30. Add them. 90 plus 30 is 120. Subtract from 180, and the third angle is 60 degrees. Notice a handy shortcut for right triangles. Since the right angle already takes 90, the other two angles must add up to just 90 between them. You might wonder why the sum is always 180. Here's a beautiful reason. Draw a line through the top vertex, parallel to the base of the triangle. Now the two slanted sides act like transversals crossing parallel lines. By the alternate interior angle rule from Session 5, the two bottom angles get copied up beside the top angle. And those three angles together lie along a straight line, which is 180 degrees. That's why it works for every triangle, not just the ones that look balanced. The GED often hides the angles behind a variable. Watch how clean this stays. Suppose the three angles are x, 2x, and 3x. Their sum must be 180, so we write x plus 2x plus 3x equals 180. That combines to 6x equals 180, so x equals 30. Now substitute back. The angles are 30, 60, and 90 degrees. Always plug x back in. The value of x by itself is usually not the angle they asked for. Here's a real-world use. A surveyor measuring a triangular plot of land only needs to measure two of its corners. The third angle comes for free. Just subtract the two measured angles from 180. No need to walk out to the far corner and measure it directly. That's the angle sum, saving real time and effort. Now the most common mistake, and it's an easy one to make. Students sometimes use 360 degrees instead of 180. Remember, 360 is a full circle, the angle all the way around a point. But the inside angles of a triangle add to 180, half of that. If your missing angle comes out huge, like 250 degrees, that's your signal you used the wrong total. Let's check your understanding. A triangle has angles of 50 degrees and 60 degrees. What is the third angle? Add the two you know to get 110, then subtract from 180. 180 minus 110 is 70 degrees. Let's recap. In every triangle, the three interior angles add up to 180 degrees. To find a missing angle, add the two you know and subtract from 180. When the angles use a variable, set the sum equal to 180, solve, and substitute back. And never confuse it with 360. That's a full circle. Excellent work on Session 8. The triangle angle sum is the workhorse of geometry, and now it's a tool you own. Next time, we'll extend one side of a triangle and discover the exterior angle, and a shortcut that saves you a step.